And today, well, we're tackling a term that sounds simple: educational technology.
Yeah, and you hear that, and most people, they probably picture, I don't know, a smart board, maybe a learning app on a tablet. But honestly, that's just scratching the surface. It's like looking at a huge building and only seeing the door handle.
Right.
So our mission today really is to get way beyond just screens and gadgets. We want to clarify what educational technology really means, this broader, sometimes surprising definition. We'll need to distinguish it from instructional technology that's a bit narrower and maybe most interestingly trace its roots way, way back. Think Stone Age.
Okay, Stone Age. So we're looking for the intellectual blueprint for education, not just the tools it uses. And to get started, let's clear up some common mistakes. The sources are pretty clear about what ET is not, right?
Oh, absolutely. They explicitly say, look, it's not just audiovisual stuff like tapes and TVs. It's not only about software or hardware.
Yeah.
And it's definitely not limited to those old teaching machines or just, the basics you cover in an intro tech class.
So if it's none of those specific things, what actually holds it all together? What's the core idea?
The core definition, when you boil it down, is pretty precise. Educational technology is the application of a body of knowledge. That's the technology part, to solving educational problems.
Applying knowledge to solve problems.
Okay, but the key thing for you to grasp is that the technology here isn't always a physical thing. It's often the systematic process of applying that knowledge. It's a way of thinking.
Okay. That definition, though, it feels like it covers two pretty different areas of work, doesn't it? How do specialists break ET down?
They do. They usually split it into two main streams. The first one, you could call it the hardware approach, or maybe technology in education. This is the one people think of. First, it's applying actual machines, physical equipment to help deliver information.
Right, the physical things, the stuff you can actually point to. So based on the source categories, this would be audio things like radios, tapes.
Exactly. Audio media, you've got visual media, simple things like charts, pictures, and audiovisual like TV, video players, and projected media too, where you need both the hardware, like a film projector, and the software, the film itself. That's ETI, the easier part to see.
But the real deep dive, it seems, begins with the second part, the software approach, or, as you said, technology of education. This sounds like where the real thinking happens.
It absolutely is. That's the intellectual heartwood. This approach means applying systematic procedures, theories, principles, often borrowed from psychology, philosophy, sociology, to actually improve the quality of education. It's less about the specific machine and more about the careful planning, the system design that happens before you even choose a tool.
So the technology is the method, the systematic process itself. What does that process actually look like? What are the steps?
Well, it covers the whole cycle. First, identifying what the educational problem really is. Then, analyzing it, what's causing it. Then you set clear, measurable objectives. What does success look like? After that, you design the solution, the intervention, and crucially, you have to evaluate. Did it work? How well? It's about making teaching less about desk work and more systematic.
Okay, so ETI is the tools, ETT is the system. And the modern view, ET3, basically says you need both working together.
That's it. ET3 integrates them. You put the man and machine efforts together, as the source says, using that systems approach. You need the smart design and the right tools. You really can't have effective technology in education without the technology of education guiding it.
That makes sense. And you mentioned psychology and philosophy feeding into this systematic approach. Let's dig into that. Where did the psychological ideas come from?
A lot of the early momentum came from behaviorist psychology. B.F. Skinner is the big name here. His work was hugely influential on this systematic way of thinking about learning.
Skinner, right. Behaviorism. And how did that translate into actual educational practices or tools?
Well, his focus on observable behavior, on stimulus and response, led directly to things like teaching machines and the whole concept of programmed instruction.
Ah, the teaching machines again.
Mhm.
What was the key psychological idea they were built on?
Two main things: reinforcement rewarding correct responses and what they called immediate knowledge of result, or ICOR. The idea was that if a student does something, they need instant feedback. Tells them if they're right, helps them correct if they're wrong. The machine was basically a way to deliver that systematic feedback consistently.
Interesting. So the machine isn't just presenting info, it's managing the learning process based on psychological principles. And you mentioned philosophy, too. How does philosophy fit into designing, say, a video lesson?
Well, ET pulls from everywhere. It's quite eclectic. Philosophers like John Amos Comenius, even John Locke way back, influenced how we think about media. Comenius, for example, really stressed that learning materials should help students move from concrete experiences, things they can touch and see, to understanding abstract ideas.
Okay, so the video shouldn't just show a tree. It needs to be part of a system that helps the student grasp the concept of, say, photosynthesis.
Exactly. Which brings us to a really important distinction, one that often trips people up. The difference between educational technology and instructional technology, IT.
Right, ET versus IT. How do they relate? Is IT just a part of ET?
Precisely. First, let's define instruction. It's usually seen as the systematic design, delivery, and evaluation of the actual teaching learning process. What happens in the classroom or the learning environment. And learning itself in this context is defined as that relatively permanent change in behavior you get from experience. Basically, teaching that actually makes a difference.
Okay, so instruction is the process, learning is the result. Where does IT fit compared to the broader ET?
IT is definitely a subset of ET. It's much narrower. Think of it like this. ET operates at the macro level. It tackles big, system-wide educational problems, like how do we design a whole new curriculum for a country? Or what are the policies for setting up educational resource centers?
Okay, big picture stuff, policy, large-scale design.
Right. Whereas IT works at the micro level. It's focused on solving specific instructional problems within a classroom or a course. Things like, how do I best manage this specific group of students? Or what's the perfect visual aid, a chart, a video clip for this particular lesson on photosynthesis?
Got it. ET is the whole building plan. IT is choosing the right hammer for a specific nail. And the goals of those IT tools, the specific media, seem pretty clear. Making learning faster, reinforcing the key message, keeping students motivated, making it feel real.
Yes, promoting realistic learning. But there's a really important warning in the sources here, too. Yes, about the misuse of media. The goal is to enhance learning and critical thinking, absolutely. But it should never be used for indoctrination. That's the term they use, practices that basically shut down a student's ability to reason independently. That's the opposite of what good instructional technology should do.
That's a crucial ethical line.
Okay,
So we've defined ET, broken it down, contrasted it with IT. Now let's look at how this whole field actually developed. You mentioned the Stone Age. That seems unexpected.
It does, doesn't it? But if you define ET as applying knowledge or tools to solve educational problems, then yes, the history is ancient. Think about early humans, those cave paintings. That wasn't just art, it was a technology for recording experiences, for communicating knowledge across time. That's a form of instructional media.
Huh. Okay, I see the connection. Using a tool paint, a rock surface to solve a problem of memory and communication.
Exactly. And consider this. The practice, even today, of using concrete objects in primary school pebbles, counting sticks to teach basic math, that directly echoes how early people used physical objects to understand quantity. It's a simple, enduring educational technology. Still works.
Fascinating. So that's phase one. What comes next? Phase two is the age of book and chalkboard.
Right. Big leap forward. Around 1456, Johann Gutenberg's printing press. That was revolutionary. Suddenly, information could be duplicated and spread on a massive scale. But this information explosion, as the source calls it, created a new problem. With more people needing education, that old model of one-on-one tutoring just wasn't practical anymore.
So how did technology solve that problem?
The solution was scale. Assemble students into larger groups, into classes. But if you have dozens of students in one room, how do you keep them focused? How does the teacher communicate effectively to all of them? You need a central focal point. And that's where the chalkboard came in. It became essential technology for mass instruction.
The simple tool solving a huge logistical problem. Okay, phase three, mass communication.
Now we're talking radio and television. This is where education starts reaching beyond the physical school walls in a big way. These technologies allowed educators to reach vast audiences, people who were geographically remote or couldn't attend traditional schools, the unreachable, as the source puts it.
And there's a specific example given, isn't there, about television in Africa?
Yes, a great piece of historical context. In 1959, the Western Nigerian government established WNTV. That was the very first television station in all of Africa. And a primary reason for setting it up was educational broadcasting, using this powerful new medium to solve the problem of reaching more learners.
Wow. So not primarily for entertainment, but for education. That's significant.
It shows the problem-solving focus. Which brings us to phase 4, the computer age. This is the era we're living in now. The computer is unique because it basically absorbed and integrated all the previous media forms.
Right. Audio, video, text, images, it all comes together. We get multimedia, digital cameras, eventually the internet, virtual reality, even things like virtual libraries.
The computer becomes this kind of universal machine for both delivering content, a technology and education, and for facilitating the planning and systems behind it, the technology of education.
This historical walk really shows how the tools change, but that core idea of applying knowledge systematically persists. And this evolution, overcoming distance and time, leads us straight into modern applications, like distance education. Right.
Absolutely. Distance education, or DE, is fundamentally defined by that separation teacher and learner are apart, geographically, maybe even in time. And technology communications bridges that gap. It's closely tied to the philosophy of open learning, too, which is all about removing barriers, age, location, prior qualifications, making education accessible.
And within DE, we have e-learning. How is that broken down?
There are two main modes you often hear about. There's synchronous e-learning.
That's real time, like a live online class, interactive.
Exactly. Everyone's logged in at the same time, interacting, like a webinar or a virtual classroom. Then there's asynchronous e-learning. That's where you access the materials on your own time, at your own pace. Think discussion forums, pre-recorded lectures. There isn't that immediate live feedback loop.
Okay, different modes for different needs. But when you're designing distance learning, choosing the right technology must involve trade-offs.
Huge trade-offs. The sources give some good examples. Take broadcast radio. It's cheap. It reaches almost everywhere. Great for remote areas. But the schedule is fixed. If you miss the broadcast, you've missed it, unless someone records it.
Right. And television.
TV adds that powerful visual element. It can be really motivating, great for demonstrations. But again, traditional broadcasts are fleeting, ephemeral. You can't easily pause, rewind, or review complex ideas.
Until recording technology became widespread anyway. And then there's CAL, computer-assisted learning.
CAL. That's kind of the digital evolution of Skinner's teaching machines. It offers the potential for truly individualized instruction, adapting to the learner's pace, ensuring they master concepts before moving on. Huge potential.
There's always a but, isn't there? What are the hurdles for CAL, especially in distance settings?
The practical challenges are significant. Cost is a big one: hardware, software, internet access. Then there's the need for digital literacy. Learners need basic computer skills. And maybe the most fundamental barrier in many parts of the world: reliable electricity. The most amazing software is useless if you can't power the computer. It highlights how the system includes the infrastructure.
It all has to work together. Okay, so we have the history of the modern tools. How do institutions actually manage all this? Where do these resources live? That brings us to resource centers.
Exactly. Educational resource centers, or ERCs. Think of them as the physical hubs designed specifically to house, organize, and help people use all these different instructional materials effectively. They're the place where the technology in education, the stuff, meets the technology of education, the system for using it.
And there's even a standardized way to name these centers depending on the educational level.
Yes, the Joint Consultative Committee on Educational Resource Centers, JCCRC, recommended a structure. At lower levels, they're often called Learning Resource Centers, LRCs. At the university or tertiary level, they might be Centers for Educational Technology, CETs. And at the government or state level, Educational Resource Centers, ERCs.
Having standard names helps everyone understand the function, I suppose.
It promotes clarity across the system. And crucially, these centers need specialized staff to run properly. You need a director, often called a media specialist, who understands the systems. You need technical media professionals who know how to operate and maintain the equipment and materials, and media aides for support. It's a whole operation.
So wrapping this all up, what's the big takeaway for you, for the listener? We started thinking ET was just gadgets. Where have we landed?
I think the biggest shift is understanding that ET is much deeper than the machines. It's fundamentally that systematic approach to the technology of education. It's rooted in theories from psychology and philosophy, and it's all aimed at solving fundamental problems in teaching and learning, problems of scale, quality, access, effectiveness.
The tools are just, well, tools. They serve the system.
Precisely. Whether you're talking about national education policy, macro-level ET, or picking a video for one specific class, micro-level IT, the underlying goal is the same: applying knowledge systematically to make sure teaching actually leads to learning. To get that relatively permanent change in behavior we talked about, that's the measure of success.
That really reframes it.
Yeah.
Okay, before we finish, you always leave us with something to think about. What's a provocative thought for today?
Okay, here it is. We've traced ET from using concrete objects, pebbles, sticks to highly abstract environments like virtual reality. Philosophers like Comenius stressed moving learners from the concrete to the abstract. So the question is, as our technology becomes more complex, more virtual, more abstract itself, what kind of philosophical shift, or maybe what new systematic design, do we need to ensure that the technology of the computer age still effectively bridges that gap? How do we make sure we're still successfully guiding learners from concrete understanding to abstract thought, even when the tools themselves are increasingly abstract?
Hmm. Does more abstract technology make it harder or easier to grasp abstract concepts? That is definitely something to chew on. Fantastic journey today. Thank you for clarifying that.
My pleasure.
And thank you for joining us on the deep dive. We'll see you next time.